and by saying hello, everybody. Welcome to this third OmegaNet webinar. And I am Henrik Kolsted from the Department of Occupational Medicine at Aarhus University Hospital in Denmark. I think we all can agree that high quality exposure assessment is a cornerstone of high quality epidemiological studies within occupational health. And today we have the right person to discuss what we mean about high quality exposure assessment. It's my pleasure to introduce Debbie Glass from Monash University and Melbourne University. She will introduce our discussion with a talk entitled Assessment of the Quality of Exposure Assessment for Epidemiology. And Deb is an occupational hygienist by training, and she has a long and strong track record within occupational epidemiology and exposure assessment. She has studied most occupational exposure, benzene, silica, asbestos, and several other carcinogens, noise, asthmagens, just to mention some. And she has applied most epidemiological designs, exposure surveys, traditional case control studies, nested case control studies, and large cohort studies of industrial populations. And also, I should mention, she has an ischemic nerve problem today. So this means that if you see Deb is moving a little bit around on her chair during his presentation, this is the reason. And Deb has accepted that if you have questions to Deb during her talk, please put them in the Q&A box or in the chat, and we will present them for Deb, or if they are better suited at the end for the common discussion, you will let us know. Right, Deb? So with these words, I would like to give the screen to you, Deb. I'm looking really much forward to hearing your talk.
Well, thank you for that very kind introduction. I'm going to share my screen now so that you can see my presentation. Share, and then I've got to do that one. Do it. Okay. So basically, I was asked to talk about how you can assess the quality of the exposure assessment done for epidemiological studies. This work was sort of drawn on work that I did and was done by others, particularly for the monograph 120 on benzene and 126 on opium, where we tried to codify the things that were interesting. So that's really where this came from. So this is not at all just my work, it's a number of other people. So the kind of exposure assessment obviously is going to vary by study, and the bigger the study, the less detail you're going to be able to go into, and probably the less precise will be the individual exposure estimates. So for cohorts, typically we see exposed, not exposed, or maybe some semi-quantitative people are put into high, medium and low groups. And that's usually the best you can do, because with very large cohorts, it's difficult to deal with people on an individual basis. You might have 10,000 people, you're not going to be able to be very precise. In a nested case control study, I think you can do better than that. You can look at some quantitative exposure estimation on an individual basis for the particular cases and their controls. And in nested studies, You're typically in one industry, which makes it a lot easier than in case control studies based in the general population, where you might have a whole lot of different industries ranging from street vendors to cabinet makers to asbestos workers to teachers to nurses, all kinds of things. And there, probably the best we can do is high, medium, and low. That's general population. Ecological studies, well, there's really not much you can do. You don't know anything about the individual people in the study. So the first thing to say about it, the exposure estimate, is the type of study and its size is going to dramatically affect the precision of the assessment that you can do. And Rob Schnatter wrote a nice paper in 2005 where he looked at the exposure assessments, risk estimates coming out of different types of studies. And you'll see that population-based case control studies, you've got quite a variation. This was relative risk for CLL. Nested case control studies came out pretty similar. Cohorts were really wildly variable in terms of the exposure assessment, probably better for the well-controlled ones than for the crude ones. And I think that part of this is to do with the precision of the exposure assessment. So what have you got to do? Well, first of all, you've really got to be systematic. You really have to try hard to avoid any bias. The usual metrics we look at are exposure, yes, no, perhaps how long people were exposed, and then a measure of intensity, which might be the average daily parts per million or milligram per meter cube. And then cumulative exposure would be the multiplication between the duration and the intensity. But those are the usual metrics that you find in studies. But there are other things that we might need to consider. For example, the pattern of exposure. So we found in the benzene work that I was doing that it looked like having a peaky exposure, a very variable exposure, was an added risk. But of course, then you need to say, well, what do you mean by a peak? We were saying, well, roughly 3 ppm, because any exposure is going to vary for anyone. So you need to decide, well, what do you mean by a peak? And then think about how frequent that might happen. So in the benzene study, if somebody was filling a tanker or a drum, a barrel, you're going to get a peak exposure as you displace the air. But for someone working on one of the reformers, less likely to get that kind of peaky exposure, except when you were perhaps dipping the tank, which you do relatively infrequently. So something else to consider. Then it looks like intermittent exposure can be a particular problem for benzene and leukemia from some animal studies. If you have a small amount of exposure regularly, it seems to depress the metabolism of benzene. And then if you have then no exposure for a period, the blood cells get a chance to multiply. And then, of course, you then whack the multiplying blood cells the next time you're exposed. So the intermittent exposure seems to be more damaging than a constant low-level exposure. And of course, we usually assume that inhalation is the major route of entry in occupational studies. But of course, you can get dermal exposure. Ingestion is pretty unlikely in most cases, but so we may need to consider dermal exposure. And then you need to consider when the exposure was relative to the disease outcome. So you might have an induction period and then a latent period. So the induction, while the thing is doing the damage in the body, silica is a good example of that. Silicosis may take many years to develop. And then after it's developed, there may be a period where it's in the body, but it hasn't been detected. So we may need to think about the highest exposure job or the most recent or the longest held job when we're thinking about the when we're looking at the exposure, which period to measure. So what are the data sources that we've got? Well, we can ask people, were you exposed, yes or no? People are good at some exposures, they're not very good at others. So they know if they did welding, but they may not know the type of gas it was. There's been work done showing that construction workers are pretty poor at knowing whether or not they had asbestos exposure, both in both directions. I mean, many older construction workers will call that cement board asbestos, even though it's not in it anymore. But that's the term that they've grown up with it. So we can do interviews or questionnaires, a more formal way of probing exposure. And some of you may have be aware of Occupational, which is a very systematic way of trying to gather that information. There may be pre-existing records. So employer records might have both the job title and the area of work, and then you can apply a gem, which is, because it's developed a priori rights, less likely to be biased. For the firefighter study that I did, the firefighters collected data on all the names of the people who went to each incident. So you could say that, you know, this person had been to 27 false alarms, 3 car fires and 4 bushfires over the year. So that was a very nice set of data that was collected completely independent of disease status, and quite detailed. Worth looking for that kind of thing if it's available. And then we come to the gold standard. What we would all love is measured exposure data. So we seldom have those measurements for the individual in the study, except perhaps for radiation badges, which are a bit of an exception. And we often end up having to extrapolate a smaller amount of data on one person to other people who do the same or similar jobs. So there's going to be some estimation involved in there. You may have to adjust it for the period. So they were getting petrol from a different refinery which had a higher benzene content, for example, was one of the things that we looked at. And then the last thing is biomarkers. That's pretty unusual and a pretty expensive thing to do. You don't see many EPI studies where the exposure assessment is based on biomarkers for obvious reasons. So I'll go into those in some detail. So then we get what kinds of study. We compare an exposed cohort to the general population. So cancer mortality in the chemical or the petroleum industry. You have exposure present in the workplace, probably no measured exposure data, certainly not going back before 1970. So we find people produce qualitative exposure as exposed, not exposed. You might have duration or era. So you were in an exposed job for this period of time. So that's the kind of thing you see in the earlier studies. And I've given you some examples there of the benzene studies that fit that profile. But we have to remember that there are possibly occupationally exposed individuals in the general population comparison group. So we may well have benzene exposed people in the general population as part of our comparison group. And that may need to consider that when we're looking at risk. The next group is where you get assessment of exposure from the job title. So you use a GEM or you use experts to allocate people or the workplaces or the job titles to exposed or not exposed. It's good if the experts can be from the specific facility or the industry sector, and they're often occupational hygienists. But you can't guarantee that they'll be familiar with all the workplaces in your study, and they may be more familiar with some than others. So you then put people into groups prior to the case identification in cohort studies. And in case control studies, of course, you've got to make sure that your assessors are case blind and not, they don't know which are the people, who are the cases and who are the controls. And again, there are examples of those from the industry if you want to see that kind of work. You can also do semi-quantitative, high, medium and low, based on the work area. Michael and the Rushton study did that. Assessment by experts from replies to individual questionnaire. So the job-specific modules that we use in case control in Occupational are an example of that, but there are some others there. They tend to be more recent than the the ones I was talking about earlier with the yes and no exposure. They're, of course, more time consuming and therefore more expensive to go to individuals. And again, you can see that it's going to be easier to do it on a case control study rather than a cohort study with lots and lots of people. And as I said before, general population studies can cover lots and lots of industries, and it's difficult to find experts who know all there is to know about all the different industries in a general population study, and experts are likely to be more expert in some areas than others. And I don't know if you're familiar with Kahneman and Tversky, but they looked at experts, and experts who are really experienced and know an awful lot tend to be more tentative than experts who are not very expert. So the more you know, the less likely you are to be very dogmatic, which is an interesting observation. So again, and you have to be careful about case status and recall bias in that work. So expert assessment using measured data. As I said, radiation badges you get, otherwise it's relatively unusual. I did come across a absolutely wonderful study of done in South Wales in Beryllium, and then they got over 200,000 personal measurements on 194 people over a period of 10 years. So then they had and also 370,000 area samples from the 101 areas. So there they had an enormous amount of data, but believe me, that's really unusual. Yep. So strong exposure assessments. You're going to have measured data from the relevant facilities, and the experts are going to be able to attribute it to individual job titles and work areas. You might have a job exposure matrix within that facility. And that's great, but you do have to watch out in terms of most EPI studies obviously go back over a long time, and job titles change and work areas change. The facility itself may change, so you need to really be sure that you understand the history of the place. And of course, you're then taking exposure data on an industry-wide basis applied to individual participants, and they might be, I don't know, taller than everyone else, and therefore their nose is out of the plume, or they might be shorter than everyone else and have their nose in the plume. Yeah, so we do have variability between workers and between days for the same worker, and we normally take an arithmetic mean of all the data and apply it to the individual. And of course that comes with some uncertainty and some lack of precision. The arithmetic mean is usually used rather than geometric mean because those are real measurements that they may have had, and we're assuming that they could have had any of those. So the arithmetic mean is a better measure of real exposure than the geometric mean, which is a description of the data rather than a dose that somebody might have had. Quantitative exposure estimates using measured data. Yep, that's great. Usually easier for a case control study, but of course, personal exposure data not available before 1970. Got to extrapolate back in time. Then you have to think about why the data was collected. It's seldom collected for EPI studies. So it's representative of the usual exposure, but by and large, they haven't measured exposure for the very low exposed people, because why would you? Why would you spend the money looking at your low exposure? So sometimes you have to guess what low means, whereas and then in compliance monitoring, if you're checking to make sure that you're complying with the law, you estimate, you measure really the higher people, and then you've got to ask yourself, well, is that typical? Is that typical of usual exposure, or have we gone in on the high exposure days? When I used to go out as an occupational hygienist, so many times the workers would say to me, you should have been here yesterday, it was much worse then. So, we need to know it's typical. You may need exposure modifiers for jobs and areas when the data was not available, may not be applicable. So going from top filling tankers where we have lots of data to bottom filling where we have a lot of modern data, to extrapolate what somebody might get at top filling when they were standing there and looking at it rather than using a gauge. You've got to factor in what that might mean in terms of the exposure. So you often need help from the people who've collected the data and knowledge of changes to the industry to correctly interpret the data that you've got and to apply it to the right people. So those are all the problems. How can we have confidence in the exposure estimation? Well, there have been a number of people who've developed techniques. So dosimetry, for example, looked at the historic benzene estimates and compared that to the frank benzene poisoning rates. And you could see they roughly followed each other. Another way of, so you want some independent verification that your numbers are about right. Schnatter et al. Did a exposure estimation quality score for the exposures, and then you take away the low quality ones and it should sharpen the risk assessments in sensitivity analysis. So that's another way of checking. Steinsvag et al. Looked at inter-rater agreement. So how well did our experts agree with each other? And you would obviously have more confidence where there was high agreement than there was low agreement. And then the other thing that we're often asked to do is to look at possible confounding exposures. And there's a very early paper by Ott who did exactly that on an individual basis, a really classy study. Obviously, less extrapolation is preferable. So this is some work that Valandren did, looking at the benzene exposure data. And what you have here is the person years on the vertical axis and the years of the person years of the study across the bottom. And you can see the proportion of data is in the grey bar. So not a great deal of data in the Canadian study, although some of it did go back quite a long way. The UK study really only had data for the recent years. And the same could be said for the Australian study, although rather more of the years were covered. So from 1980 onwards, you'll see this is a more recent study. So a higher proportion of the people were covered by data that had been collected contemporaneously. And that's another nice way of looking at the quality of the work. So I said I'd come back to biological markers, and here there's some examples of EPI studies that have done that from back to 1982. Usually what you get is individual data attributed to a group. Sometimes it's from the actual individual in the study, but that's relatively unusual. And of course, the reason for that is the few studies have been done because it's very expensive to collect biological samples. It can be quite intrusive. It's generally, the techniques aren't available for all exposures. So there isn't a measure of, no, I'm blanking on that now, but there aren't measures for all the things that we're interested in. And of course, in very large cohorts, it will be quite difficult to get very good precision, and it would be incredibly expensive, unless the data are already collected. So the big exception to that, of course, is lead. And we often have quite a lot of lead in blood data for quite large people because it's collected for regulatory purposes. I think that the evolution in understanding, particularly on benzene, which is a substance close to my heart, we see that the crude exposure data, the crude exposed, not exposed, identified that AML risk was increased. Once we started getting better exposure estimates, quantitative ones, you could start to see that different leukemia subtypes had different levels of risk. Once you get paired exposure and outcome data, you can see the mechanisms of toxicity, and the pharmacokinetic data can tell you what choice of metric we should be using for epidemiology. So, for example, we do need to look at peakiness of exposure because the enzymes that deal with benzene can saturate. And of course, with a better choice of metric and more precise exposure estimates, we get less misclassification, you get more precise risk estimates, and you can identify risks from lower exposure. So I think it's important that we pursue some of these ways of doing things to do it better. I must say that was one of the things that drew me from hygiene into epidemiology was looking at the epi around, and they were doing exposed, not exposed. That wasn't any help to me. I needed to know how much did that so that we can set sensible exposure limits, occupational exposure limits, TLVs, that kind of thing. So to summarize, what do we need? We need, is it systematic for the exposed and of course for the controls? Where relevant. Was the exposure assessment independent of, or at least done before the health outcome was measured? Unbiased, therefore. Could the reference group include exposed individuals? And what was the definition of exposed that was used? And of course of unexposed. When we say they're not exposed, what do we mean by that? There's almost no one in the Western world who's not exposed to benzene if they drive a car. When was the exposure in relation to the outcome? So considering induction and latency. What was the exposure route? As I said before, usually inhalation, but skin and ingestion might be possible. And what were the exposure metrics? They could be qualitative, duration, intensity, cumulative, as I've said before. Were there any validation or checks on the exposure estimates that would make you feel confident that they were accurate or precise at least, and have co-exposures been considered? So that's really the summary set of questions that IARC developed for the monograph, or we developed for the monographs to look at the quality of the exposure assessments. And that's it.
Thank you very much, Debbie. Thank you for a very nice talk. And I think there's a lot of questions out there. And as far as I understand, you might unmute. So please use the raise hand function or the chat if you have questions for Deb. Or just unmute. When you are thinking about good questions to raise, Deb, I would like, could you please, from your own research, give an example of exposure assessment that we could learn from? Some of your high quality. What could you give an example?
Well, we had a cohort of petroleum industry workers, and we had a nested case control study of leukemias and lymphomas, multiple myeloma, and did an exposure assessment on that. And really, I drew on work that Tom Armstrong had done on the Canadian cohort and Leslie Rushton had done on the UK cohort, and drew on what they'd done. And for each individual, we had a base estimate of exposure, which then had multipliers depending on the extrapolation that we needed to do. So top to bottom loading, for example, or the number of barrels that were filled a day at that facility, or the benzene content of the petrol that they were filling, or some of them brought in benzene toluene xylene mix from some coke ovens and would add that. So you'd have to do a multiplier up for that. So they were on how many times they dipped tanks, what form of dipping it was. So we had something like 28 different base estimates and a lot of things that we would tweak to try and get the as precise an estimate as we could for that person in that period. So we knew a lot about which refinery the terminal sourced from, and how much filling they did, what the technology on the filling, whether it was a short stub or a long stub, and so it was quite a lot of interviewing of people to find out what technology they used. that was one thing. The firefighter study, I said before, we had this fantastic database of where after each incident, the lead firefighter has to write down who went and classify it, and then that's all centrally gathered in a systematic way. So we could see that the volunteer, and this was for volunteers and for paid firefighters. So volunteer firefighters had typically been to about 300 incidents in their career, whereas the paid firefighters would go to perhaps 1,000 over the career. So we could see, and differences between different states. So on an individual basis, we had an estimate of the kind of things they'd gone to, and how many fires, how many structure fires, how many vegetation fires, how many vehicle fires. It was a lovely resource. Yeah.
Thank you, Deb. Thank you very much. I think I see there is a question from Susana Viegas. Please, Susana, can you unmute?
Yes, hello everyone, and thank you for allowing me to make a comment and also a question. And thank you, Deborah, for the nice presentation. Well, it's from a very experienced exposure assessor for sure, and it was very good to have these kind of examples, and also the kind of message that we sometimes hear in the workplaces. One of the things that claim my attention also relate with the benzene occupational exposure is the fact that it's indeed important to know something about the toxicokinetics of the substance to understand what kind of exposure metric we should use, because it will be for sure more related with the health effect. And maybe past one of my experience related with formaldehyde exposure assessment, that it seems that also the health effects in the nasopharyngeal cancer are more related with peak exposures and not so much with the average exposure, the TWH 8 hours exposure. So yes, just to give them one more example. The one question that I would like also to present is the exposure to mixtures, because I think that is really a challenge, and it is the most real exposure scenario in the workplace, and brings a lot of things that we have to consider even when we are trying to relate exposure with health effects. What is, if the health effect is related with the single exposure, or is related with the fact that the work exposed to several contaminants? And I think also that is a very challenging process. We have now several tools to do a better job on that scope, but still a lot to learn. Thank you for your considerations about this question. Thank you so much.
Yes, you're right. I didn't cover multiple exposures. I just briefly mentioned, co-exposures, but yes, that is something which gets very complicated to take into account. Good point.
Okay. I can see France Labrèche also have a good question here for Deborah and all of us. I think a comment about Robbins E or other comparable tools for quality assessment. Can please, France, can you unmute? And we can have the question from you.
Well, I haven't used either of those tools. I've seen presentations on them, and I thought they looked really interesting and really helpful. So I'm actually by no means an expert on that. I think I should go and have a go at them, but I can't. I haven't so far. Perhaps someone else here has used those and wants to comment on that.
Hello, I can now. I can talk and speak. Hello, Deborah. Yeah,
Hello.
well, I was wondering, because I'm trying to do a systematic review now, not on that topic, one of the topics that you presented, and I have reserved. I don't know if this is a word in English. I have some we say réservation, some reserve, des réserves.
Reservations, yeah.
Yeah, okay, reservations on using these tools, which are, well, they're tools or sort of checklists. So I think that, as you mentioned earlier, that experts that are very experts are more less dogmatic. And to me, the checklists are a bit dogmatic. So I was wondering what you thought about that. Okay, so well, perhaps you try them, and then we can talk about that at the next meeting.
Sorry, I'm not an expert on it.
That's all right. Nor am I.
I think it's good to have that kind of thing to make you think it through, but I'm not sure how, sometimes you have to tailor what you do to what's available rather than to a checklist, So I could do different things with the firefighters than I could do with the benzene one. And the type of study, as I said before, often dictates, what's possible.
Yes, you're right. Okay, thank you very much.
Okay, thank you. I can see also there is a question from Vivi. Can you please unmute, Vivi? It should be possible now, I think. Or does Katarina has to assist you?
Okay, maybe can you hear me now?
You're on there, yeah.
Okay, so thanks, Debbie. That was great. So I want to hear your view on using quantitative job exposure matrices in order to obtain quantitative exposure estimates in large cohorts, because I noticed that you stated that normally we are left with semi-quantitative estimates for large cohorts. So what is your view on this? And do you think that this might be useful for setting occupational exposure limits? Or can you elaborate a bit on that?
Look, I think if you've got a quantitative gem, I know there are some about that's applicable, great. They are enormously time consuming to develop, but I think there's at least one for silica that I know of, fantastic, but they are pretty unusual. My concern is that that you get data from one place and you're putting it into a gem, and then you're assuming that everyone will fit that gem. So I think you need to do quite a lot of hard thinking to make sure it's really applicable. But if it's been set up and why not, as I say.
Thanks.
Thanks, Deb. And in line with that, you mentioned your study on benzene on the petroleum workers. How did you decide on exposure level? Was this based on all available information and expert allocation, or did you use a statistical model for that?
Well, we got an enormous amount of data from Australia where they'd done measurements and talked to the hygienists about how far back it went and whether it had changed and what it was collected on. Some of the data we couldn't use because there was insufficient circumstantial data around it, so you didn't know what type of drum filling they'd been doing, what the technology was. Where was I going with that? Yes, so basically we got the hygienists, sat them down. I said, this is how I'm going to use it. There's this and there's this question, tried to iron out the difficulties. And I learned a lot about changes that had happened in the Australian oil industry over the period and what was and wasn't applicable. Yeah, you just have to have an enormous eye for the detail, I suppose, because and talk to hygienists, because they understand about what determines exposure and what may affect exposure. The workforce themselves don't always understand, so they might, if you say, do you have a system that takes the dust out of the air, they'll point to a fan in the wall miles away, which, yes, it extracts it from the general atmosphere, but not until after it's gone past their face. So it's not really reducing exposure. So yeah, you've got to, yeah, also, I mean, well, it was an interesting process. If you talk to the workforce, they would tell you about the time they jumped into a vat in order to retrieve a spanner, and you get the impression that this was something that happened often. Then if you talk to the management, they tell you that everything was always fantastic. And what was interesting, of course, is that the workers would therefore be overestimating exposure with the war stories, and the management would be underestimating exposure and therefore overestimating risk. It was quite an interesting dynamic that went on with that. So you were trying to navigate between those about what realistically did happen. How often might a tanker driver overfill the tanker?
So these large amount of information might be lost in a statistical model.
Well, you did a little bit of modeling, but not much, because you were trying to always tailor it to the individual and take into account their particular circumstances, and that was often different. But that's why you end up with, but you can do that for a nested case control study, because we had something like only 500 or 600 people. Whereas, if you've got 10,000 people, you can't do that. You have to do the statistical modeling. Or at least I do. I'm not having lots of money and infinite time.
Debbie, you are ready for more questions, aren't you?
Sure.
So please feel free. You mentioned peak exposures, the importance of peak exposure.
Yeah.
How to quantify? What do you think about short-term measurements that we often leave out when we do exposure assessment, because we think these are not representative, these are hotspot measurements? Are they applicable for peak exposure measurements assessment? Yeah.
Well, sometimes that's important, and I think it's going back to the issue of what the biology is behind it. And if you think that so a very short exposure, a peak of heat might not matter because your body's dealing with it. Whereas a very short exposure, but a short but very high exposure, if it tips you into a different way of dealing with the contaminant, could be a problem. So I think you're trying to look for the biology behind it, really, to see whether it's important.
Yeah.
So I don't think a 5-second peak of lead is that important, but it might be for some other material.
But how do you identify the peaks?
Well, yes, because you're seldom there to measure it when it happens. What we did in benzene was to look at the kind of work that people did, and you could predict the likelihood of there being a peak exposure around particular sorts of work. So drum filling is a classic case. My words are going. It's late. Filling drums, filling tankers, spillages, dipping tanks to see how much is left in them, or taking samples of tanks were things that the hygienist knew were likely to have high exposures. And so we were looking for how often that was done. And we knew, for example, up until 1955, sites had to dip every tank every day for the tax purposes. So there was a lot more dipping going on in those days, and that was all open dipping. Whereas now they have much more closed dipping. You can see, you're not actually having to climb up and look in to do it. So things change. So dipping at one stage happened more frequently, more likely to give you high exposures, less likely now with different forms of technology. So we were just trying to track how these changes happened. But I don't think it's possible to do how much, because things vary over the day, how much, how high the peak might go, too hard. But you could say, well, these were the jobs that we're going to allocate a peak exposure to.
Excellent. Excellent. Thank you.
Right now, we're grappling with peak exposures in silica. I don't know if you have seen, we're doing some work on cutting artificial stone for kitchens, and the cuttings now has to be done in Victoria, has to be done wet. But when they go out on site and do installations, it's often not wet because they don't want to mess up somebody's new kitchen. And so you can get very short, very high exposures, but the current silica measurement techniques don't allow us to measure silica because you can't get enough onto the filter to actually measure it in that short time. So what you're doing is looking at a dust track or something like that, and of course that's all dust, not just silica. But you can see there are very high peaks. So we're trying to see at the moment whether or not that matters with silica, because I would have said 5 years ago, peaks, it's the total amount of stuff. But with this dry cutting, we get such high peaks that I think it might be making a difference.
Interesting. I can see Michelle has a question for you.
Hi, Debbie. Michelle here. Thank you for a great presentation. I see that you have a lot of experience in different types of occupational exposure assessment for chemicals. And I was wondering, based on all of your experiences, if you have any kind of insight for the new ongoing studies on occupational exposure to COVID-19. And there's some efforts to develop GEMS for those types of studies.
I don't really know anything about this, and I think it's a really hard thing to do. I mean, at least when you study chemicals, they aren't multiplying as you look at them. Whereas, COVID, they're growing, and more of them get produced. I think it's a very hard thing to do. My only 3 halfpence worth on COVID is that I think the community should stop focusing so much on fomites and touching and washing your hands, and they should pay more attention to the aerosols, because I think that's where the real risks are. I mean, we've had, I'm touching wood here, we've had not too much transmission in Australia, but what's come out, people enter the country, they go into a quarantine hotel, and there have been cases coming out of the quarantine hotel, and it's clearly been aerosol transmission because people have been shut up in their own rooms. One outbreak was as a result of someone using a nebulizer for his asthma meds, and that got out and affected a number of people. So I think there's been undue focus on, well, at least not undue, not enough focus on aerosol transmission, in my view.
I can see Damien, you also have a question for Debbie. Are you there, Damien, somewhere?
I put the question in the chat. It's a slightly naughty one. I just wondered, can we predefine circumstances in which we know a hygiene assessment is going to genuinely add value and be able to improve our exposure-response relationship? Or do we need to do the study in order to be able to answer that question?
Oh, well, there's never one study, is there?
No, true.
So I think what happens is that we tend to look at a study, and then it gives us ideas on what might be a better metric. And so you try and then refine that. So Leslie's study of the benzene in the UK case control study was looking at, they had something like 5 different measures of peakiness, and you know, that was an enormous amount of work and really didn't show very much. So, you know, we chose something much simpler that we could put, you know, more precision into doing. And I think when we did the pooled study for the Canadian, the UK, and the Australian study, you know, we chose one definition and put quite a lot of effort into looking at the peak as defined for that study, and I think we did show something there. So I think we always build on what other people have done. I guess. Does that answer your question or not?
Yes.
Are there more questions out there? Our next OmegaNet webinar is about night work.
Oh.
And do you have any opinion about how to assess night work exposure?
Oh, well, I did a little bit of a study with Lynn Fritchie. We were thinking about breast cancer and shift work. And the more I looked into how we might define exposure, the more difficult I thought it was. I think it's a really hard thing. You were looking at, you know, whether the shifts rotated in one direction or another, whether it included particular periods of night, whether or not you needed a certain number of days together, or whether, you know, would that be a different risk to being on permanent nights, for example, and then the person's own biology affecting, you know, some people adapt better than others, so they, you know, so I would be probably okay at night work, but I'd definitely not be good at shifts that started at you know 5 in the morning. I couldn't do that. So I just I take my hat off to the people who do those. I think it's an enormously difficult study with so many different variables that might affect risk.
Thank you, Debbie. Are there more questions for Debbie or commentaries or something for all of us? Or everything is for all of us? If not,
one thing I'd like us to be able to do is to develop some more techniques to measure quality. I think that's not done very much, sort of the validation of what we do. I think that would be an interesting thing to kind of look at.
Yeah, you mentioned this. You referred a study who did the quality assessment of the exposure assessment, and then did the sensitivity analysis based on this. Could you give some recommendations?
Yeah, that was our that was the pooled study with the 3 Canadian, the UK, and the Australian study, and we could look at the studies, and there were a number of things that affected what we felt was a quality assessment. The first one was the amount of information we had about a job. So if somebody just says supervisor, it can be difficult in retrospect to know, you know, what they were doing and how hands-on that was. So that would automatically get a pretty low, particularly if it was gone back in time. So back in time, less information about the actual job, you know, would give it a low quality score. And then the more recent stuff where we had recent data, plenty of measured data, a clearly defined job at a place we were sure of, we could give it a high quality. I mean, in some of the UK studies, you know, they were going back to the 1930s, and the facilities were shut. Nobody could remember what they did. You know, so you were going. So we could, you know, it was crew 1, 2, 3. You know, so this is awful. This is really good, and this stuff's in the middle. But you know, you could give it some sense of, okay, what happens if we chuck out all the ones that have a poor quality? You know, are we getting an increased risk? You know, are we reducing the misclassification? So, and I think that was an interesting thing to do, and not that difficult.
Yeah. And if I understand you, you were systematic and you used objective criteria like we should do when we do occupational exposure assessment.
We went through and, you know,
Excellent. I think I will close the webinar now with these words. Thank you very much, Deb, for your nice talk and a nice discussion. And then, do you have something you would say? No?
Well, thank you for listening.
Yes. Yes, but then we will meet. We will meet again June the 8th at 4:00 p.m. Central European Time, and the title of that webinar is the cohort design the preferable approach in studies on night work? So it sounds like that case control studies might be better. So we are looking much forward to that discussion. So thank you very much, everybody. Ingrid or Michelle, will you say something from the core group?
No, thanks very much, Debbie. Great presentation, and thank you, Henrik, for chairing today. You did a great job.
Okay. Goodbye, everybody. Or Ingrid, you are on mute.
No, that's fine. Thank you, Deb. Thank you, Henrik, and thank you, everyone.